what this discussion tonight is, well, what are heat networks in the sense of how can they deliver a solution in the future against client needs and developer needs and the UK needs, and balancing that against alternatives and also legislation and policy and how we can decarbonize heat in particular in the UK. So that's the sort of area of discussion and topic that I'll be covering in these dozen or so slides that I've put together here. So without further ado, just a very quick introduction to Innovate. As Rick said there, we were formed in 2014. 3 directors founded the company, myself and my colleague Steve and Joe, Steve Marsh and Joanne Longdon. And our aim at that point was to represent the client, because I want to say the client represent people who were developing schemes, and help them in the regards that we saw in 2013-14, that they didn't understand heat networks and what they were actually trying to procure and how to procure it, and even what they should be procuring and what it meant, etc. So whilst we were in our roles back at E.ON, it was difficult to sort of interact with customers who weren't able to interact with us in the way that we needed to develop. So we saw a gap in the market to say, well, actually, our talents and our skills can actually be better used by the client rather than the actual provider, which has been proven very successful in the last 9 years or so. We offer a completely independent, comprehensive, and personal consultancy service, as it says on the screen there, right the way through from initial discussion of potential networks, so feasibility assessments and heat mapping functions such as that. We can then engage with the market, as in the market providers, to make sure that the market providers return bids sometimes to clients that are relevant and focused. But very much one of our focuses and very much one of our talents is the commercial modeling and the structuring of the investment. So what does this actually look like commercially? Who puts the money in? Who makes the return on that cash? Whose cash is it? How does that function in the sense of the delivery of the product? That's one of our specialities through Innovate. And then beyond the implementation of the heat network, a very, very big expansion potential in the market generally, but specifically for Innovate, is what we call our EAMS service, which is the ESCO asset management service. So once heat networks are installed, they absolutely need to be maintained and managed and looked after in as much detail as putting them together. So we'll come on to a little bit of that later on. We've expanded the Innovate team from the initial 3 of us back in 2014. There's now up to 20 of us. As of next month, there'll be a 20th member, so a vastly expanding team to cover the market. I won't go into every one of those. And some of the clients that we work with across the board, they're major housing developers, councils throughout the land, UK councils up in Scotland, London, Liverpool, Manchester, etc., and also private developers and developers of energy from waste. So enough of Innovate. That's who we are. That's who we represent. We are a market leading consultancy in the development of heat networks. So heat networks, the heat network rollout that we foresee in the future. Now, I've been in a 2 or 3 hour meeting this afternoon where we've talked about the past 10 years, and we also then talked about the next 10 years. And I really do think that we're at that sort of crossroads in the industry. For the past 10 years, we've been talking to developers, taking examples such as Berkeley Homes, for instance, any developer, Persimmon, etc. And they would talk to us about their scheme and their site and how it can be developed successfully on a heat network. Where the UK government is and where this industry will be, I think, in the future, is a far grander scale than that. There's a huge ambition of the government to expand the use of heat networks by a huge margin. The current connection of heat customers to heat networks in the UK is roughly 2 to 3%. of UK homes and businesses are connected to heat networks. Very, very small margin. By mid-century, so not long now, when we think about it, 20, 25 years, the ambition is to get that up to about 20%. So a fifth of UK homes and businesses to be connected to some form of heat networks. Now that's a huge, huge undertaking and huge ambition. And we'll talk about it later in the slides about how realistic that is and what the constraints around that are. But you can see there is an ambition at government level, at UK level, to expand heat networks as a function. I've put a comment on there from the Minister for Climate Change, Lord Callanan, who's a big supporter of heat networks. Almost a third of all UK carbon emissions come from heating, and addressing this is a vital part of tackling pollution and driving down bills and reducing the reliance on fossil fuels. And there was an announcement last week that I took this from, where he instituted a new fund that could be accessed by developers and suppliers alike. And we want to create opportunities and green jobs and investment across the country. So recognizing that there's a huge network expansion to be planned, there has to be huge investment in resource and the provision of that resource and training, etc. So there is a major crossroads in heat networks in the UK happening currently, and you'll see the outputs of that in the coming years. And what I actually personally met with Lord Callanan a few months ago, and he essentially wants to create this heat network, or the perception of heat networks, to be the fourth major utility service. So you can see that electricity grid, gas network, water service. Well, heat networks need to be part and parcel of the utility service of the UK. And obviously, one of the advantages of heat networks is they have a strong advantage of being able to utilize fuels from several sources, and are not a specific answer to a specific question in a building. It can be rolled out across multiple buildings at a single decarbonisation change. So one of the major reasons the government are very focused on heat networks is the ability to change a lot of heat to a lot of buildings, particularly in city centres, via one method of production rather than looking at individual answers to individual buildings and problems. The other point to make here is one of the decarbonisation challenges that I haven't gone into in detail on the slide here is the current building number rather than any new build. The decarbonisation of the current heat is very important. We're not going to get anywhere near our target by just being reliant upon new heat networks or new builds connected to heat networks. We have to decarbonise the existing stock and the existing buildings, and therefore many of those are large city centre buildings running on high temperature heat networks, high temperature systems within the buildings, and things such as heat pumps and so on. Individual heat pumps into those buildings are not necessarily going to provide a good economic service. So decarbonising city zones within major UK centres is a huge task and a huge ambition for the government. What I mentioned just now is the heat sources and the availability of those heat sources onto heat networks. And of course, there is gas at the minute, and traditionally, looking back on the last 10 years, gas has been probably the #1 supplier of heat onto heat networks through the utilisation of gas CHP units. So that is not necessarily the way forward. Everybody understands that, and the utilisation of gas CHP is vastly reducing. And one of the tasks to undertake as a network industry is to decarbonise those existing systems, and taking out gas CHP systems as they come to the end of their useful life. Of course, we can utilise and operate from the electricity grid, and so centralised heat pump systems. The use of heat pumps in a centralised location really helps to decarbonise areas such as new build, as I said before, and the lower temperatures they can operate on, but also the city centre schemes alongside other things to boost temperatures in buildings, etc. So we can certainly utilize the electricity grid. One of the major steps forward, I think, in the past couple of years has been the acknowledgement of utilizing waste heat and the energy from waste and industry. And rather than creating new methods of heat to be used in the network, simply using the heat that's already around in our environment is absolutely fundamental to the success of decarbonising heat in the future. And so energy from waste suppliers, energy from waste operators are becoming more and more interested in being able to make available their heat from their plants from a carbon reduction point of view, to enable them to reduce their own carbon footprint, but also to enable them potentially to make that into an asset that derives value for them, while still obviously deriving value for the heat network. So energy from waste is going to be a huge supplier of heat into heat networks in the future. Newer technologies such as the utilization of either large scale or even now smaller scale data centers to be used in parallel with either electricity grid, heat pumps, or gas VHPs, etc., becoming a little bit more common now and useful and understood, and how that is interacted, or how we interact with the data center providers to take that heat is becoming more common. Industry methodologies, taking heat from huge industrial centers, can be useful nowadays and understood far better nowadays than was the case 5 to 10 years ago. So all these things are available, all these things will play a part, and of course it can be a combination of all those things to get the perfect mix. Not forgetting, of course, what we call 5th generation networks, in that heating and cooling can be provided in certain circumstances, and so utilizing the heat from one source and to be used as cooling in the other, and vice versa. So all these things are now forming part and parcel of thinking and how we actually utilize and create the value for the customer. The other point that isn't on the slide there is the operation, the utilization of solar, and utilizing the solar energy into the operation of the energy center and the generation plant. So there is wide focus now on not only utilizing heat and dealing with heat, but how do we do that, from what source, probably multiple, and also utilizing the land area available to us to even create solar power as well. So I mentioned before about Innovate's speciality. One of our specialities is looking at all those opportunities and creating the commerciality of how that actually is taken forward. So policy, I'll just minimize myself there so I can see the text on the screen. Government is really behind heat networks. That is an absolute fact in the past 5 to 10 years, and there continues to be strong funding provision from central government all the way through to local government utilisation of it, and that can be used for feasibility studies to enable things to get started in the first place, right the way through to capital investment through loans and grants. Over the past 5 or 6 years, there's been two main schemes of where funding has played a huge part in the development of schemes. One is the HNIP scheme, which is the Heat Network Investment Project. That provided funds of 320 million across numerous schemes up until a couple of years ago. Huge benefit to the market, and major networks were instigated on the back of HNIP funding. That has been replaced now by what's called the Green Heat Network Fund, the GHNF, and that is currently in operation, and there are quarterly rounds of application for funds. And again, that can be utilised for commercialisation of heat networks through to grant, in this case, capital grants to applicants show and demonstrate what they call bang for buck. So if they can demonstrate that the scheme really decarbonises for minimum investment through grant, then you're more successful or more able to be successful in gaining grant funding for your scheme. Again, Innovate has vast experience of being successful in gaining those grants. But the government recognises that to decarbonise huge areas needs huge investment in legislation. And beyond the initial availability of funding, there is more policy and ambition of the government to create in city centres what will become heat zones or heat zoning areas. So the major UK cities are undergoing an analysis of heat mapping, and then also analysis of how those heat maps within those city centres can be then demonstrated to provide value to the market in redlining an area to be a heat network zone. And what that means is that the properties within each of those zones that are identified will be in some way encouraged, mandated, whatever the terminology is, to become part of that network. And this is the sort of government saying that it's going to be very difficult to decarbonize these inner city buildings individually. We don't have the time to look at that individually, but if we can create a single heat network that those buildings can connect into, then that is decarbonizing difficult areas in a far quicker way than leaving each building to its own devices. Now, this heating legislation is still going through consultation and development, and so this is not settled yet. However, it is clear that that's the direction of travel that will be undertaken, and therefore, if you are looking at any major city in the UK, it will form or have within it some kind of heat zone that will establish a heat delivery in that area. That is a major change from 2 to 5 to 10 years ago, a huge difference in attitude from the government, and one that is to be encouraged. On the back of that, there is going to be regulation. It's not a regulated industry, the heat network industry currently. It is not and never has been a regulated industry. However, there has been some kind of self-regulation to a certain degree through voluntary bodies and associations, primarily the Heat Trust from a residential point of view. However, it will be regulated. The government has announced, or did announce in 2021, that the industry will become regulated from about 2025. Now, it keeps going back that date, to be absolutely frank with you all, but it will be circa mid-20s that this industry in general will become a regulated industry, which helps in various regards, but it will be a major step forward. The details of this are still to be announced, as I've just said there. However, it is fair to say that many of the installations, certainly over the past 10 to 15 years, have self-regulated to a certain degree, and many of the standards that have been adopted over the past few years will be taken into regulation, and we don't expect major changes in standards, etc., from where we currently are, but we'll wait to see what that entails when regulation is fully announced. I suspect it's been slightly delayed because of the current volatility in the market, and speaking to a couple of people within BEIS recently, there has been sort of resource issues in pushing that forward because of other areas of development of such as things like the energy government price guarantee, that sort of thing. So there is a slight delay to regulation, but it's certainly coming. One thing that really interests me in particular is the pricing to customers and the perception of customers to heat networks, particularly for residential customers. And of course, and many people on this call tonight will understand that the investment required in installing the network results in the operators needing to secure revenue from the investment. So therefore, there is a stifling of competition within that network zone, of course. Now we need to look at that perception and understand that perception. Now, the main point of argument there, or two main points of argument, is standards of service and, of course, pricing. So all networks should provide a heat service at a price that is directly comparable to the equivalent service provided by an alternative supply, such as gas, tradition, and or electricity moving forward. So, and that's more common, obviously, for new schemes. So there has to be, and there will be, a comparison of heat network charging and tariff and pricing that enables it to be compared with the equivalent non-heat network service, such as gas and or electricity. That charging methodology has then to be captured in the contract and supply contract, and therefore retains that commercial advantage for the duration of the service. So typically, heat networks have operational licenses for sort of 25 to anything beyond up to 80 years, but typically between 25 and 40 years. Major point there, and we have to understand there are bad examples out there, and those bad examples create uncertainty. However, with regulation and with understanding more around customer pricing and regulation and how that is going to be rolled out, that will become the norm to ensure that prices to customers that have no alternative potentially of connecting into any other method of heat are kept in line with and are comparable and competitive to the alternative. It's an absolute fundamental and something that really needs to be understood and concentrated upon. So some heat network advantages. There are advantages and challenges, of course, and it obviously provides or should provide a lower cost service to users when all the factors of heat provision are considered. So absolutely should be a commercial service that delivers competitiveness to customers. It provides flexibility to the operator to derive heat from numerous sources, low carbon sources, and change that over time. So it provides a simple upgrade to central plant rather than having to change building by building sources of carbon. And the cost of installation, or some of the cost of the installation, or sometimes all of the cost of the installation, can be taken away from the developer and into the hands of the operator. So in return of that 25 to 40 year revenue stream, it could be argued that some of the schemes can actually be paid for in its entirety by the heat network provider, which takes a lot of the initial cost away from developers and so on, which is a great advantage in certain circumstances. And then, as we said just now, the industry is being developed and has been developed recently in a manner to be regulated, and should provide consistent and quality services, both technically and at a customer level. That's what the aim of heat networks is, and that's what the aim of heat networks should be. And that's understood. That hasn't always been the case. The challenges. One thing I always get from customers in terms of challenges is the perception. So poorly performing, old, usually council-owned schemes from the 60s, the 70s and so on, perhaps or even unmetered back then. And the analogy I always derive is, well, in the 1960s, you bought a car, Hillman Imp. That's not the car that you buy today and operate today. Heat networks are a completely and utterly different animal to their traditional start back in those early days. So there is no comparison, both from a design point of view, an operation point of view, an efficiency point of view, a data gathering point of view, a technology point of view, to any of the older, poorly performing, I have to say, some of the old poorer performing city centre schemes and housing association schemes. So the perception, perhaps from the older generation, is that they're not good things. They weren't good things back then, but they are completely different nowadays. So getting over that perception is a challenge. Also, just the general misunderstanding of what a heat network is. And what I mean by that is a customer that's on a heat network. What does that actually mean? And what are they responsible for? What they're not responsible for? What should be provided? How should it be provided? There's got to be an understanding of that. And there's not enough effort, in my view, on making sure that that is understood by all aspects and all users of the scheme. So we have to get that improved. By doing that, we have to ensure a consistent and quality service then, and that means the management service that we were talking about earlier on. So not just developing these schemes and then leaving them to their own devices, but actively managing and policing that scheme on a consistent basis is fundamental to a successful operation. And the challenge there is to make sure that there is enough resource and there's enough personnel to develop the opportunities. Because an increase from 2%, 3% up to 20% is a huge task, and therefore resource and training and the ability to derive experienced personnel is a huge challenge for the industry. And so those are amongst the challenges for the industry, amongst others. And that's the end of the overview, really, because what I wanted to do is just put my opinion out there, put the Innovate opinion out there, and talk about the regulatory change from where we were to where we were going, and then perhaps just instigate a few questions, answers, discussion between the group on anything that you need more information on. So thanks for the 10-15 minutes.
Thank you very much, Steve. That was a really interesting talk. I have to apologize for people that I didn't make it clear at the beginning that you should, if you want to ask a question, type your question into the chat. But I see a few people have done that anyway, so that's great. And what I propose to do now is I will read those questions out to Steve. And while he's attempting to answer those, and we're having a discussion about that perhaps, anybody else that has any questions that Steve has raised in his talk, or more generally about heat networks, please find the chat and type your question in there, and I'll come to you in due course. So hopefully that's okay. I'll go from the top. We have a question here from Duncan, which is, how does the 20% UK target for district heat networks compare to other countries?
Good question, Duncan. Is that Duncan Child? Hello, Duncan.
Yes, it is.
I'm not sure in terms of other countries' numbers. I don't have the numbers to hand here, but as you're probably aware, and maybe most people on this call, Scandinavia is the sort of the centre of district heating, really, in terms of utilisation. Germany to a certain extent, Czech Republic to a certain extent. Traditionally, they have been council-owned networks. However, that's changed slightly with private investment going into there. But in terms of the numbers, not sure of the percentage. However, for the UK, my personal opinion is 20% is very high. It's an ambitious target, 20%. If we can get 10 to 15% in that time frame, I think that we would be performing very well. But I suppose we set ourselves a stretch target and see where we get to. Because I have to say, just to finish off the answer to that, heat networks are not the answer every time. You know, I'm not here to say heat networks are the answer to every scenario. They're not. I think what we need to establish is, why are heat networks advantageous in certain areas? What role do they play in the wider portfolio of all the solutions that we need to have in the next 30 years? And as I say, going from 2%, 3% up to 10, 15% will be a huge step forward. So I didn't really answer your question, Duncan, but hopefully along that way.
Thanks, Steve. I had a question, which is, you mentioned waste heat as a source, but some people think that organizations will become more and more thermally efficient, and so availability of waste heat might decline in the future. So do you think there's going to be much scope for taking low temperature waste heat, for example, from rivers and lakes, and using heat pumps to increase the temperature and injecting that into heat networks? I know it's being done in some schemes in the UK, but is that going to become a bigger technology in the future, I think?
It is, yeah. That's a definite solution, Rick. We're developing a couple of schemes now with water source heat pumps as the primary generator of the initial heat, and then, as you say, with other sources to boost that temperature where required. But yes, taking heat from the scheme I'm referring to up in Glasgow, from the River Clyde. We're also looking at a huge heat pump in the River Mersey for the Mersey heat scheme in Liverpool there. And yes, all those things will be part of the future. Now, in terms of waste heat, there are huge, or there's a huge availability of heat. And as I said to you before, there are not many heat networks right now. However, the availability of heat far outweighs the current heat network utilization, and will do for many years to come. So the utilization of that heat, and I call it waste heat. There's two scenarios, as you may know, obviously, in your role, is that there is waste heat, as in heat that's gone through the turbine, etc., and been expelled up into the skies. But there's also waste heat as part of the actual process of the turbine. So where you take that heat from can be classified as different grades of heat, and therefore different temperatures, etc. So where it's horses for courses on each scheme, but we're trying to utilize more and more and more of just the waste heat. Just it's going nowhere. It's no value to anyone. So putting that lower grade heat into heat networks really does help the performance of heat pumps.
Thank you. Thanks. Question from Ademo. What are your thoughts on strategic mapping of heat in relation to established waste heat sources for optimal delivery of the technology?
I think I understand the question as there is a heat available in a certain location. Therefore, the heat mapping around that source and being able to utilize that heat in that local area. Is that am I understanding the question right? That if I do, and that's the question, then yes, absolutely. There should be, or there is currently, there is vast work going on around almost every energy from waste plant, in particular in the UK, to utilize the heat where possible. This also helps the heat emitter, if you like, the energy from waste provider, to reduce their own carbon footprint, which will become increasingly valuable to them as UK ETS and things like that in the future move into a more stringent tax, and inverted commas, on the emission of carbon. And so the utilization of that heat is now, it hasn't been in the past, but it's now a more valuable commodity to the heat network, to the heat generator to utilize within a heat network. And we have several clients now that we're working with to establish heat availability and or heat mapping the availability around their plants. There is even now discussions that we're involved in to utilize what's called heat batteries. So taking that heat from those plants into a battery, in inverted commas. I said right at the beginning, I'm not technical, so bear with me with my technical phraseology, but taking those and then delivering it to where the heat is required. So there is big innovation, and utilization of energy from waste will be huge.
Thank you. Hopefully that answered Ademo's question. If not, Ademo, please feel free to type a clarification in the chat. Question from Phoebin, and this doesn't sound exactly like a heat network question, but perhaps you'd have an opinion on it, Steve, anyway. What can be done to reduce energy consumption due to boiler usage in Grade 2 listed historic buildings?
Yeah, I think touched on this earlier on. They're big and they're leaky, and it's all about efficiency in those particular cases. And I would be very much an advocate of fabric first and efficiency first before you even think about generation and utilization of heat. So absolutely, it needs to be building fabric first in that case. However, if they are on or within city centres, for instance, and they are potentially on the route of a heat network, then yeah, taking heat from the heat network once the efficiency measures have taken place can help to reduce their gas consumption, because they'd be taking heat from the network, and then potentially using things again like heat pumps to boost the temperatures if required in the older buildings. So yes, we can certainly help to reduce gas networks in those buildings by that method.
Thanks. Question from Scott Borders. As an organisation with available waste heat at 70 degrees C hot water in the form of 70 degrees centigrade hot water, what capacity output in megawatts becomes interesting and potentially viable to become a contributor to a district heat network?
Horrible answer, but horses for courses. You know, it depends on the locality, etc. In terms of capacity, I can't really give you an answer to that, really, depending on the locality to the heat network, the off takers of that heat network. But I would, as a general rule, as a third party heat offtake, you're probably looking at 2 or 3 megawatts, sort of thought, as a sensible starting point. Although it could be lower than that if circumstances dictated. So we'd have to talk, was it Scott? Sorry, we'd have to talk individually about what that is. You said it was 70 degrees, but what's the reliability? We then start to talk about what's the guarantees of that heat. There's all sorts of things to talk about, but 3 megawatts seems a reasonable starting point.
Thanks. So might be some business there for you and Scott, perhaps.
Yeah.
Chris Ball has a question. How do you overcome challenges to decarbonize heat networks that are operating at higher temperature to meet older building design temperatures, for example, 80 degrees C?
Yeah, we touched on it, I think, in the presentation there. That, first of all, absolutely fabric first, and all cases are absolutely got to be looked at. But we're looking at a major hotel in the middle of Manchester with this very point. So we have to look at, first of all, the age of the current system that's operational. Is there any capital investment going to be made, etc., and can that capital investment be made in reducing the need for temperatures potentially? I know it's always difficult in older buildings, etc. But utilizing heat networks, especially heat networks that are maybe centrally operated with either heat pumps or a combination of heat from energy from waste plants, etc. Well, if it's energy from waste, it can be delivered at a higher temperature anyway. But if it's delivered at sort of a lower temperature to suit the heat pump, then it can be locally boosted within particular buildings. I really am, by the way, apologies again, but I really am at the edge of my technical abilities answering these questions. I'm not a heat network designer. I'm a commercial developer. However, utilizing heat at a lower temperature and boosting it locally is going to be a common thing moving forward.
Thanks. A question from John Barton. What's the minimum viable building density or housing density for which heat networks are viable, are considered?
Yeah, that is a very good question, very good apt question. In terms of number, first of all, in terms of number, heat networks, it's a bit of a misnomer, heat networks as well, because there's heat networks and there's communal heat. I mean, it's very similar, but not quite the same. But we get commercial use out of sort of 200 or 300 nowadays, 200 or 300 new build, potentially within apartment block type developments. However, a few schemes are now lower density than that, and I'm hesitating to give a number, but we have low density heat networks essentially, if the circumstances are right in terms of the ability of the creation of the heat in the first place, the cost of that heat, and then the longevity of the contract. Again, we talk about the investment in the longevity of the contract. You can get a typical housing development, low-rise housing development, to work on heat networks should your heat be run efficiently and on waste sources. So we've got several in development that you would describe as typical low density housing. So whatever the number is around typical low density housing, we're starting to see those connected to heat networks.
Thanks.
Certainly not the 5-6 bedroom, home once every half a mile. That's not conducive to heat networks. Okay.
Question from Ilaria Stocci. I hope I've said that correctly. Will ground source heat pump systems, particularly those with large arrays of boreholes, play a big role in heat networks?
Again, similar answer to before. Yes, they will. We're developing a couple in the London area now with ground bore arrays. We're also talking to major deep geothermal suppliers and looking at what that or what role that has to play in certain areas of the country where it's conducive to installation. And it's always a challenge there about the day one load in terms of the investment in the drill and the day one load that's derived from it. But yes, they will play a part, as will ground source in the right location. Definitely, it would be a very good source of heat.
Thanks. A question on solar heat. You mentioned solar heat in your presentation, but one of the problems with solar heat is that most of it's available at a time of year when it's needed least. So do you see heat networks in the future being fed from some kind of seasonal heat storage system? I know the Danes are looking at this, but I'm not aware of anybody else doing this.
Yeah, well, I mentioned solar. I might have communicated that wrong. The use of solar currently, or the use of solar that we're involved in, certainly, is the use of the electricity that the solar is creating to be used in the operation of the heat network. Yeah. And so, if it's the same and have a solar investment to make, they can utilize their heat very efficiently by using it as part of the heat network. So it wasn't solar heat particularly; it was using the electricity from the solar. So that might not have been of communication 10 minutes or so ago. But again, I talked just now about heat batteries and the availability of heat batteries and where they take those heat sources from. So as ever, innovation is derived from necessity, or the other way around. Necessity derives innovation. And I have to say, in the past 2 or 3 years, there's been so many discussions that I mean, I'm sure I'm only in a small fraction of the discussions that are actually taking place. But everything and anything that can help heat networks to become established in the sense of creating heat efficiently, utilization of waste heat efficiently, utilization of heat and transferring that to somewhere else via batteries, underground seasonal storage of heat, they're all going to become very, very important and part of the mix that's going to be available, because it has to be, because as people on this call know, we're not going to generate all our heat via one method. It has to be a portfolio of several different methods, and they're all, if they're commercial and somebody wants to invest, they will be utilized. Thanks.
There's a couple more questions from one from Ademo again and one from Phoebin. I'll do Ademo's first. He thanks you for your answer to his earlier question, but he says he's interested to know, because you're just talking about heat pumps, heat batteries just then, how the commercial viability of heat battery technology will be affected by the pricing, and over how many years? So do you see this technology taking off quickly, or is it going to be slow? What do you think?
Well, to answer your question, in terms of quickly, I have a meeting with a major council on Friday to talk about this particular technology. So it's happening. Whether it happens next week or next year, it is definitely under consideration in that particular case. Yeah. And of course, everything revolves around price, and everything revolves around the commercial terms of the heat. And what I mean by that is the risk of that heat, the guarantee of the load and the demand, the guarantee of the provision of the heat. That's the nature of where we are. We cannot now connect into a gas network, expect that gas to be there forever. We have to look at the sources of heat and how that source is derived, paid for, and guaranteed, because there has to be all those things in place before it becomes investable. And as I said right at the beginning, we are not technical designers, we are commercial designers. So we look at all those commercial aspects and understand what it is to pay for, de-risk, contract, and in terms of the source of the heat, but also then pushing that forward to customers in the sense of, well, what does that mean to customers? How can we guarantee heat to customers? How do we guarantee the risk, etc.? That's what we do, and that's what our role is in every single heat network that we're involved in, and every single one is different. So we have to look at all those risks.
Thanks.
Not to say that all those risks cannot be overcome. They can, and they are being. So whilst it sounds very difficult to do, it's actually becoming more and more common to do.
Thank you. Question from Phoebin. Then, what type of heat pumps do you think will be more efficient, specifically for high-rise buildings in the long run? Ground source, whether it's vertical, borehole type ground source or horizontal slinkies, or water source, which we mentioned before, or air source heat pumps, particularly for high-rise buildings?
Yeah, again, technically, I'm not here to answer that technically. However, commercially, ground source is better than air source from an efficiency point of view, as you know. Reliability in terms of the heat availability, the non-seasonality of that, etc. So ground source, and to a certain extent water source, although water source probably much more expensive than or currently anyway, depending on the scale. Air source plays a part, of course it will, and it will play a part going forward, air source heat pumps. Hopefully, you guys on the call probably know better than me if the efficiencies of those can be improved over time. The cost of those can come down over time with investment and numbers rising, etc. But you're right. I mean, air source in particular are least efficient when you most need them, so not great from that point of view. However, if you get the pricing right and make sure that it's efficiently operated, or as efficiently operated as possible, then they're all going to play a part. If I was to choose right now, I prefer ground source, but that's just me.
Thanks. And that's the last question, but I've got one more I wanted to ask, if possible, before we go, unless anybody else wants to type one in quickly. But it's about the tunneling for the heat pumps, or the trenching. And I saw the heat network going in. Sorry, not heat pumps, heat networks. I saw the network going in Leicester when that was put in, and it seemed quite a disruptive process, really. The digging and then the covering up. The road was not completely out of action. It was down from 2 carriageways to 1 for several weeks. Are there any sort of new technologies or new techniques for tunneling in a less disruptive way, or for piping in a less disruptive way?
I'd love to say yes, but I can't.
All right.
I don't think there are. I mean, it is a hole in the ground with pipes in there, and maybe there's somebody on the call who can answer better than I. But no, unfortunately, Rick, it is an installation in a trench. The actual pipe itself can now be more of a plastic composition rather than the steel composition in the past, although steel has still got a part to play, specifically on major mains and that sort of thing. But no, I mean, I live just 10 miles north of Stoke-on-Trent. The last time I drove through Stoke-on-Trent by the railway station there, I was held up by a heat network installation. So I feel your pain. As I drove past, I saw the big hole there in the ground. But it is going to be and has been disruptive, and unless somebody can enlighten me, then I don't know the answer to that. Okay,
thanks. Well, I found that really interesting. Thank you very much, Steve. And looking at the interactions in the chat, I think our attendees did as well. So that was great. And just a reminder to everybody that this recording will be available on the East Midlands Energy Institute website. And in a few days, I'm sure the PDFs will be available there as well. So thanks again to Steve Hunt for a very interesting talk. And I just see there's one more question. Ademo's got one more question just before we disappear. Sorry about this, Steve. What model of pricing do you suggest for the rate and tariff setting of heat network operation?
What I missed the first part of that. Say again.
The model of pricing for the rate and tariff setting. If you wanted to access the heat network and take heat from it, how would you charge somebody for that?
Well, it's very basic in the sense of there's a tariff, obviously, and there's a standing charge. And the tariff and the standing charge combined need to be more commercial than the alternative. And with heat, as I said right at the beginning, let's use the word monopoly. Once they're in and you're connected to it, is a monopoly situation currently. And that will remain so for quite a while yet, and regulation will help along that way. But let's be clear, it has to be commercially attractive to anybody connecting to it. And how do you analyze that? How do you say, well, this is commercially attractive? You have to take, well, what's the alternative? So in the past, that has been, well, if you connect to a gas main and you run a gas boiler, over 10 years, these are your costs, or predicted costs based on gas prices. So therefore, the 10 years being connected to this network, need to be less than that, essentially, equivalent to or less than that. So the pricing mechanism has to be thought about very, very clearly from the beginning, demonstrated to the customer that it is competitive, and agreed with the customer that it's competitive, because the last thing I always think, Rick, is I can say to a customer, this is competitive, but if the customer doesn't agree with me, then we've got a problem. So we have to organize, well, what is the comparator, agree the comparator, and then make the connection and the operational performance over 10 years competitive to that comparator. And more often than not, we can do that. We can do that. And believe me, there's not much margin in these things. They do not make a fortune. Heat networks are very, very tight commercially. So they have to be described as such. And very importantly, and I think I made the point in the presentation, I can't remember, is that once a price is agreed, it is captured in contract. So therefore, there is no ability then for either party to change that methodology without both parties' consent. So there isn't suddenly a 20% hike because they are in a monopoly. It's the opposite, actually. They have to be maintained and regulated because they're in a monopoly. So that is a very, very important aspect of what we do.
Thank you. That's made me think all sorts of questions, but I won't.
It's a whole different topic, pricing, but and currently with the current volatility in the market and the budget announcement tomorrow, I could work 27 hours a day just on pricing just at the minute, but it's a very, very important topic. Because just to finish off, what I want to create as an industry, I want to create people wanting to be part of a heat network. I don't want to try and foist heat networks onto people who don't want to be on them. We want to create an industry that's low carbon, cheap, reliable, regulated, and actually, why isn't there a heat network in my area? I'd like to be connected, please. So that's I mean, it's a huge undertaking, that, but that's the perception change that we want to try and create to allow people to see the benefits of heat networks, because they're bloody great. Heat networks are great, or should be. So let's try and do it.
Thank you. Just a comment. I remember seeing something from a Danish person who'd seen the Danish heat networks going in, and he said it was done in such a way with government subsidy, whether it's local government or national, that you'd have to be stupid not to.
Yes.
You'd have to be mad not to connect. Everybody wanted to, and so it just made it so straightforward. Well,
just an example of that, Rick. Just to finish off, sorry to carry on. We actually work for and on behalf of Leeds City Council. Now, Leeds City Council have a heat network derived from a waste facility just outside the boundary there. And 3 or 4 years ago, when we first, or perhaps 5 years ago, when we first started to try and get, our role was to connect people to that heat network on behalf of Leeds. So interacting with developers, interacting with current building operators and owners, etc. It was a relatively difficult task to have a conversation with. As COP26 in particular in Glasgow 2 years ago, but as the volatility in the market just now, the uncertainty around gas, the transition, the corporate need to decarbonize, etc., etc. We have more people knocking on our door now than we ever have to go and knock on their door. Wow, there's a heat network in the area. Let's talk to Leeds and get connected. For 2 reasons. One, it's a good price, and 2, it's low carbon, and all their cost of developing their own solution goes away. You have a heat network outside your door, connect to it. It's a no-brainer. So Leeds can be held up as an example of where we're trying to get all the major cities in the UK.
That's great. That sounds like a very good place to finish. So thanks again, Steve. Fascinating talk. And hope to hear from you again someday.
Thanks, Rick. And again, thanks to Duncan for the initial introduction a few weeks ago. Thank you.
Cheers. Goodbye.
Bye-bye.